it's just going to be me and Charlie or Pin. Is it?
So you have 5 people, but how many presenting?
Wait, sorry, we only have 4?
Your team only 4?
Yeah.
Okay. So who is here? Wait, who is in your team? Is it Jonathan?
Me and Charlie or Charlie Huang?
Charlie. So Charlie Wang. Is it Huang?
Yep.
So let me write a note here. So it's Jonathan.
Yep.
And then is it Ping Shu? Okay.
Yep, that's me.
And then who's else?
Just us 2 presenting today.
So two percent, but so is it still 5 member?
No, we have 4 members.
You only 4 member. So so here who is let me. So you have Jonathan, you have the Ping Shu, and
Yep.
then who else? Is it SHAI?
Yeah, Shai and Bevan.
Okay. So C hair is Shu hair is not here. Is not your team.
Is his last name Gandhi?
I've got that, Arthur. I've got that sorted out. It's fine.
Okay. Thanks. Hi, Jason.
Yeah, that's all right.
Yep.
Okay.
We started recording, so should we start playing?
Yes, you can start.
All right, so we chose to do Zeno's paradox of motion. And
recording in progress.
Using the tortoise. So Zeno's paradoxes are a set of philosophical problems generally thought to have been devised by Greek philosopher Zeno of Elea. Zeno's paradoxes have been debated for roughly 2,500 years by philosophers, mathematicians, and physicists, with no clear consensus being reached.
You can turn your sound up.
The 3 paradoxes of motion by Zeno are the dichotomy paradox, Achilles and the tortoise, and the arrow paradox.
Turn the sound up.
All 3 posit that motion is an illusion, opposed to what one may believe based on their senses. Zeno's paradoxes describe what have come to be known as supertasks, or tasks with infinite steps to be completed within a finite time. By definition, a task with infinitely many steps cannot be completed, as there is always a next step, which is the basis of confusion with the paradoxes and implies that motion is not possible. This report will mainly be focusing on the paradox of Achilles and the tortoise, which concerns a race between the fleet-footed Greek hero and a slow-moving tortoise. The 2 runners start moving at the same time. However, the tortoise has been given a head start, let's say 100 meters. In order for Achilles to overtake the tortoise, he must first catch up to the tortoise. Assuming that Achilles runs at a faster rate than the tortoise, he will close the distance between himself and the tortoise. However, once Achilles has reached the starting position of the tortoise would have inevitably created a new gap. Although the new gap is smaller than the first, there is still a finite distance that he must cover before reaching the tortoise. Once again, Achilles covers the new gap made by the tortoise. However, the tortoise has yet again created another smaller gap. As we can see, no matter how many times we repeat this cycle, the outcome remains the same. Achilles can never catch up to the tortoise. However, from a physical point of view, we know that this isn't possible, as a human runner could obviously overtake a tortoise in a race. The problem has something to do with our perception of infinity. Using the sum of an infinite series and applying it to the paradox of Achilles and the tortoise, we can show that even if length and time are infinitely divisible, an interval may be travelled. In maths, we have divergent and convergent series. The most obvious divergent series is the sum of the set of positive integers, which goes on forever to infinity. Applying this to the paradox, if Achilles had to cover these sorts of distances over the course of the race, in other words, if the tortoise were making progressively larger gaps rather than smaller ones, Achilles would never catch the tortoise. Now let's consider the following convergent series. Although the numbers go on forever, the series converges with a solution of 1. As long as Achilles is making the gaps smaller at a sufficiently fast rate so that the distances look more or less like this equation, he will complete the series in a measurable amount of time and catch the tortoise. All in all, we can graphically show that reality would look similar to this, since Achilles would catch up or overtake the tortoise at some point. However, the graph for the paradox would look like this instead, where Achilles would seemingly slow down as he approaches the tortoise. Achilles constantly approaches the tortoise but can never quite touch it, essentially making the turtle a limit. In conclusion, the paradox reveals a mismatch between the way we think about the world and the way the world actually is. From a mathematical point of view, Achilles can never overtake the tortoise, no matter how quickly Achilles closes each gap, by virtue of a continuous cycle of ever-decreasing gaps between the two races. However, from a physical, real-world point of view, a faster motion can obviously take over a slower motion, given an infinite amount of time, contrary to Zeno's reasoning.
Should I stop screen sharing?
Yes, please. Okay. Yes, good illustration. Okay.